Hey everyone, and welcome to our pilot first episode of some conversation that just don't have a name yet, but we are working on that. And today we will talk with our guest Tom about a great article that he wrote to Talsec uh, documentation. Yep, this one. Thanks, Majid. But first, let's probably introduce ourselves. Oh, first, my name is Oleksandr Leushchenko. I'm a Google developer expert in Flutter and Dart and engineering manager at British fintech company called Tide. And we have Majid here.
Thank you very much, Alexander. So my name is Majid. I am a Google developer expert for Flutter and Dart. I'm also very passionate about app security, and these days also it's part of my job to focus on security. So that's why I'm here with these amazing guys.
Nice. Tomáš, maybe you want to be next?
Which one? You didn't choose.
Yep, you.
Okay. Thank you. Harry, very happy to be there as I was really thrilled about this call. I'm Thomas and I'm representing Talsec, where my role is mostly about mobile security consulting, reverse engineering, and my daily bread and butter is explaining mobile security concepts related to runtime application self-protection technology. So that's me.
Amazing. Thank you so much. And last but definitely not least, our guest, our star of this episode. Tom, do you want to introduce yourself?
Yes, thank you. So my name is Tomáš Skýpala, or you can call me Tom. I've been developing mobile software for 10 years now. So I went through a lot of companies, different companies, working on different projects, different scales. Yeah, I've originally even been an Android software developer. Nowadays, like for past approximately 5 years, I've been an iOS developer specifically. So that's me.
Nice. Thank you so much for the introduction. And probably we may start with the article itself. That's a great article, but maybe for those of our audience, those folks who haven't read it yet, maybe you can provide a short summary. Like, what is Unlocking Reliable Crash Tracking article about?
Yeah, so basically the idea came up as a plan to develop a somehow more transparent way to track crashes in production because we as a Talsec don't really have anything in place in production to track crashes or issues with performance. So it felt like a kind of a blind spot. I've basically taken up the initiative to research and try to implement some proof of concept of tracking crashes and all the reporting incorporated in it. So basically went through a lot of third-party solutions, checked their documentations, tried implementing all of them, namely Datadog, Sentry, Firebase Crashlytics, Bugsnag, maybe even more. I've then boiled down my research to just, I think, 4 of them, and then quickly realized that since Talsec is really security and privacy focused, the service system as a service solutions are not really applicable for us or are really missing a lot of points that we require. So I've researched custom implementation, you could say, like, in general, and found out that maybe that will be the best way to approach this problem and solution.
Great. And in the end, you choose PLCrashReporter. Who stands behind PLCrashReporter?
Yes, I found out it by accident. PLCrashReporter is an open source framework available freely on GitHub. Interestingly, it's been developed and it's being developed by Microsoft. So that's an interesting point because Microsoft and basically iOS, macOS, watchOS, specifically or only framework. That's really interesting combination. But yeah, thankfully it's being developed by mainly Microsoft developers. So even though one might say that Microsoft is known to abandon projects, and there might be a risk to further development, but the issues are really nicely discussed and replied
Mm.
to. And also the framework itself, it's simple in its concept, and anyone can fork it and modify it themselves in the worst case
Yeah.
scenario.
And it's open source. Microsoft and Apple, I think, has quite a long history of collaboration, and one can say that Microsoft saved Apple at some point in history. But speaking of the framework, you mentioned that it's open sourced, and indeed, I wouldn't say that we should not really care about whether the framework will be abandoned by Microsoft, because you can fork it, you can improve it, and work on it further. And surely that was one of the key factors that you used in your comparison in your article. Which other factors you would recommend engineers to consider when they are choosing crash tracking framework?
Most of the solutions available are third-party services, so definitely one should check ideally the GitHub repos that companies provide. Ideally, it should be that both client and server is open source, that then one can basically check all the inner workings and all the data that's accessed by these frameworks. But I think the only one of these like third-party system as a service solutions that I've checked that was fully open source was Sentry, which also provides a self-hosted option. However, the self-hosted option was really discouraged by a lot of people that had experience with it. So I really just tried to implement it myself, and also experienced a lot of issues already in the initialization. So that didn't seem like a good way or good path to go. The other ones usually have at least the client open source, which is the most important one to be able to check. But for example, Google with Firebase and Crashlytics really doesn't have anything open source. And even their pricing is like pay as you go. So you basically know nothing in advance.
Yeah, so just to add to your response, like things like licensing or maybe support, and obviously cost matters too. And of course, you need to choose the one that suits your situation the best. I have one more question regarding this open source nature. You mentioned in your articles that many third-party crash tracking services collect and store data in ways that may not align with some security policies in your company. How can developers verify what data is being collected and ensure compliance with their security standards?
Yes. Basically, the easier answer or the easier part of the answer is like what data is or should or we assume is being accessed and collected. There are also the documentation oftentimes or usually actually contains, that's the word, contains the list of all the data that's collected due to basically wide availability of GDPR laws and stuff like this that
Mhm.
developers definitely have to be wary of. And however, unless we look directly at the code of the client framework, we might never know what's actually being accessed. And the harder part of the answer is that I had little success finding out how is the data stored on the device. Because if you imagine your app crashing, it doesn't really send the report right away, which is something that
Mhm.
it's obvious because
Yeah,
it's just crashed.
because
So
the app
cannot,
crashed.
Yes.
it cannot send a network request and successfully like check if it did go through. So all the frameworks store the crash data, and they store it in some way. However, I had little to no success finding out in what way, in what fashion, what everything is being stored with these third-party crash trackers, which really makes it easily really dangerous thing to incorporate if you're in your app if you work with critical data, personal data, for example, even credit card numbers, input data. It could be anything. And if it's stored in just basic storage, which it most probably is, it can be attacked, especially on jailbroken devices. And yeah, the documentation
definitely.
didn't really tell anything about it. Their focus was always on the sanitization of personal data, but that was within the reports already that come to the server. So one might never know what's actually or how securely it's stored.
Yeah. So pro tip from security crowd, don't jailbreak, don't root your device unless you have a reason to, unless you understand what you're doing. But I have a question here, like let's probably deep dive into this topic a little bit further. Let's imagine that I created a mobile application and I used already some solution for crash tracking, whether it's PLCrashReporter or any other. How can I ensure that the implementation is secure and effective? Probably the only way for me is to read the source code or, I don't know, try to intercept traffic. Other, any, I don't know, tips you can provide? How can I ensure that my application is safe to use, safe for my users?
To fully know or purely know, you would have to even maybe decompile the source and check the traffic like bit by bit.
Well, hard
But,
code way.
but yeah, that's really not an feasible way for most of the people. I would definitely recommend trying to find all the info that you need in the documentation and
Mhm.
trying to maybe even communicate with the company or create the framework. Like if there's something really missing that you are afraid of, be it the GDPR protected data or how the data is combined, because even that is protected by GDPR. And then from the functionality point of view, I think people should or developers should focus on working in like edge cases, one might call it, because most of the frameworks have async processes that initialize the crash tracking, and it might not be fully initialized once the app is crashing at the startup. Also, I think developers should check how the framework behaves without internet, like within
Mhm.
multiple crashes.
Yeah.
If it stores multiple reports or if it's gathered in one large report, what's the limit? Because people can be or users can be out of connection. And something that I've even experienced and I think I consider really crucial, even a fatal error within the frameworks that I've checked, Wing, Datadog, and Bugsnag, is that I also personally use a third-party VPN, like virtual private network, and basically all the communication might be blocked by the VPN. So no crash reports suddenly. Nothing is crashing from the reporter's point of view. So one should definitely check this if this is not really a use case, and oftentimes use case with their users, because then one still like the developer still might be blind to these crashes from users that use these third party
Makes
VPNs.
sense. And I think you mentioned that in your article, there was a comparison like whether PLCrashReporter will work with other solutions. So I assume you would recommend to implement multiple solutions for crash monitoring, right?
Yes, that's also a good point. The crash trackers especially if the developer is developing, like in our case, SDK, you need to ensure that the crash tracking you are using is not interfering with the crash tracking your client might be using, because it does collide sometimes.
Mhm. Makes perfect sense. At the beginning of our conversation, you mentioned that you switched from Android to iOS, and your article is all about iOS. Any hints for fellow Android engineers? What crash reporting solution would you recommend for Android?
Yeah, so honestly, I focused on the iOS primarily, but I did some research and a little bit of analysis of Android counterparts. And the one that really stood out, or the one solution that seemed to be a good way to go, was ACRA, which I think it originally was another crash reporter for Android, but nowadays they call it App Crash Reports for Android. So it might be that originally they felt a bit more goofy than they are nowadays, because it's a really mature project. It's more than 10 years old, and I think their description says that it's used by over 10,000 apps with like millions of users. Might say that it's really mature. So I would recommend checking that, and maybe it fits the use case, fits the requirements. And my personal opinion is, if you can go with the custom solution, don't be afraid to, because in like high level point of view, it's really not that complicated to implement. And if you don't need like super graphical web based analytics about it, you will be happy with the basic reports. You can even be doing the analysis later, the graphical analysis bit, if you need to. And you're not
That makes
having really any critical third party dependency that might not work once. For example, new Android, new iOS version is released and you suddenly are dependent on something like this.
Yeah. At the same time, I faced that several times in my career, that if you're creating your own solution, you have to maintain it. You need to test it on beta versions, in some experimental environments. There always will be one device in some country that just doesn't work with, and you have no idea why. So I guess it's also valid to say that if you're unsure what you're doing, pick the most popular solution. Like pick Firebase, pick Datadog, and they will work for you.
Yes,
They're
that's
quite
a good
mature.
point. That's a good point. But at the same time, I would say that this is a really low level thing to, or
Mhm.
a really low level thing to be like incompatible suddenly, because it's working with the really bottom of the callbacks, system callbacks that usually don't change that much. But of course, if you want really quick solution, don't go into custom solution.
Yeah. And the question here, let's dive into this topic. I know that Datadog and Firebase, they provide much richer, like they have more than just crash monitoring. There are tons of other functionalities quite useful for engineers. Do you think that crash reporting alone is sufficient for diagnosis issues? Let's focus, for example, on issues only in the application. And how does it contributes to overall observability? Like maybe tools and best practices you would recommend for a more comprehensive approach?
But to start from basically the end, for production issues and for production crashes, customer issues, the crash reporters usually are one of the only, if not the only thing developer can implement, aside from logging, like basic logging, right? The crash reporters actually oftentimes also provide the feature to reports, like basically customer support style report an issue, like the GUI and features that once just basically callbacks. and user is presented with some input dialog that integrates with the crash tracker. And for I think usually they have also like performance metrics. So it's not really, once again, magic. The developers have to know which part of the app they want to track. If it's not just a startup time and something like this, they need to set up the profiler and basically turn it on and turn it off, where they want to basically track the performance. But then before the production, which I would say is the even more important part of the development to grasp the quality assurance and then make sure it works. There, I think my recommendation is basically test as much as you feasibly can, make it as automated as you can. What I would recommend is make a multi-level kind of automation or multi-stage that, for example, feature branches contain some of the most crucial tests. Then RC, like release candidate branches, contain most of the tests that can be run, and also integrate nightly tests that run every single day and can be ideally checked by also non-developers. For example, snapshot tests that basically do, in basic sense, screenshots of certain parts, and well, basically anyone can look at the highlighted failed part of the snapshot test and report it right away. So nightly snapshot tests are really valuable. And I think then at the very start of the development, it's crucial to think about all the edge cases and all the issues that need to be solved and tracked and looked at and ideally tested as well. So
Yeah.
basically start with the plan, continues with the good management and good development, and it's supported with the automated tests and ends with production crash tracking.
Yeah, thanks for these recommendations. Indeed, it's super important to think in advance before you release your application and try to predict problems that your users might see. I really appreciate that you mentioned logs there, because clearly logs are super important when you are trying to understand what's wrong with the application. Why, as mobile engineers, we cannot say it works on my machine. Doesn't really matter. It must work elsewhere, like everywhere. And not only crash reportings are important, logs are very important too. And usually such tools as crash monitoring, SDKs, they provide the possibility to send some logs also. And that's another good root source of vulnerabilities, right? Personal data in logs. And I think that might be one of topics that we would want to discuss in one of our later episodes. And I know that right now there is a trend from moving away from these kind of separate sources for monitoring into something that's usually called observability 2.0, or just observability. That's probably a new word. And I highly recommend to anyone book Observability Engineering by Charity Majors. Just an amazing book that at some point really changed the way I think about observability monitoring and all that other stuff. But yeah, thank you so much for this conversation. It was really interesting. Majid, Tomáš, maybe you have any questions?
I probably have one because you mentioned about this library, and probably we're going to have many audiences looking at this video, and then they say, okay, I'm not actually an iOS developer right now. How can I look at it from a different angle? If I work with Flutter, for example, or a cross-platform application, how this can help then? How can those developers look into these custom kind of crash reporting frameworks? And does it mean that, for example, you mentioned two of them? Of course, this one was the one that we were talking about, the PL Crash Reporter. And another one you mentioned was for the Android. And this one was the one you mentioned, Akra.
Yes, Accra.
Yes. So how do you look at these two for like multi-platform app builders? Where does that fit? Should they look into that or not? Is there any framework that actually consolidate both into one, something like that?
I would say you've already made it really hard to support one platform with or two platforms with one code. Don't make it even harder. I don't have really a lot of experience with multi-platform, but the third-party crash tracking system as a service solutions support usually even the multi-platform frameworks. Check those primarily. If you're interested, go dive deeper into even these custom solutions, but I think it will be much more tricky to implement
Mhm.
your own solution. But I honestly cannot say in practice. I didn't have
Okay, nice.
have a lot of
Absolutely. I think we slightly discussed that, right? If you have no idea what you're doing, just pick the most popular option, and most probably it's already cross-platform.
Sure. Yes, absolutely. So one more question then for you. For now, let's say this library, someone is landing of your suggestion and they figure out for some reason, let's put it like they want to have the company wants to have full control over the entire crash report. Like everything that goes over the wire needs to even be like in the full control. In this case, they want to go for a custom solution, and this is what you suggest and what you talked about, right? The PLCrashReporter for iOS. And the question right now for a little bit like developers who doesn't have that much experience with this kind of like custom reporting, can you just briefly, like highly overview saying, what does this mean even using this? What should I do? There is obviously some implementation. Like here, if you want to doing a iOS, you implement this crash report. Okay, very nice. But where does the data go? So there is this is supposed to be a framework only on the iOS, right? But the crash report needs to be stored somewhere. How does that work? Can you explain for those who are not really familiar with that, especially for particular custom solution like this?
Yes, the way it is designed to work, this PL Crash Reporter basically later wraps around the system callback. That's I think exactly called uncaught crash handler.
Mm-hmm.
That's really available in through Objective C, and it wraps around it. It makes the reports. It also stores the report on the device, and then the next start, as I've said, it cannot do anything once the app crashes. So with the next start, it can check the stored crash reports, and you basically implement a backend or endpoint call similarly to anything like similar, like for
Okay,
example,
so
logging.
then it's on you, on your backend
Yeah,
developers, to
yes,
actually create a backend, a database, store it there. And that's the reason we're saying go for the most popular crash, because there's a lot to maintain here, right? I just wanted to emphasize like what are going to be more than just the library implementing in iOS to be implemented. It's not just the library itself,
oh
it's
yes,
also the whole stack.
definitely. Or I usually imagine if someone is interested in like crash reporting already, it should be like after, for example, the logging or something like that, like really basic. And if you have logging set up, logging database, logs, logged communication, then you can simply add this to that make a new table that will be that will contain those reports and make a simple endpoint for it. Will be accessed by the app and be quote unquote that simple.
Well, that's interesting. So one last crazy question. So this is for out of my curiosity, and it's a crazy one. So imagine that now I want to go for this custom solution, and it's open source. So I can read the code and I see how is the crash kind of format is generated at the end. Would it be possible that I actually use this, control my crashes and reports and logs and everything, but then connect it via an API, for example, store it in convert this crash report to a Sentry, for example, format, and then store it into Sentry?
If you implemented the self-hosted option, because I don't think Sentry will.
Sentry was an example. Any crash, like whatever a third party that actually provides an API that you can send stack trace and logs and so on. Can
That's
I
the problem.
just do that?
I don't. They provide like API directly. They just basically provide the client framework that communicates automatically. That's also what I meant with the check those edge cases, like the user's device doesn't have internet, it breaks out within the upstart, whether the reports will be resent or if the send fails, the report will be lost forever. Check all these because the third party client framework, they behave themselves like in a way that it's really a black box. You don't control how the report is sent.
Okay, that's interesting. But I've seen something very interesting in this library. Just a quick note, and then I'll shut my mouth. And this part is talking about the crash report itself. And it was saying that this is going to be a protobuf encoded message, which is interesting. Okay, that's good. We understand why, probably. But that was saying, in addition to that, actually you can get this and convert it to Apple standard iPhone text format, which I was thinking then you will technically can use maybe any other kind of library or third party that can store the Apple standard iPhone text format. So use this library and convert it to that and then store it somewhere that supports this standard. Just crazy idea, right? So I wonder if this is even like a feasible option. Like you should do that or not. Developers a little bit senior and crazy comes and say, hey, now we're going to control over our logs and we're going to control all over our text. Should they do that, or do you think it's not a good idea?
It's not a really good idea, but honestly, you've reminded me of one thing. The Datadog, funnily enough, it has the client app open source or the client framework. It uses PLCrashReporter.
Oh,
Like
okay.
it uses this very library. That's one of the things that I found out while checking those like interactions. That suddenly I had in log message that the PL crash tracker was already initialized. Like it basically tries to block double initialization. And once I had Datadog initialize, I tried to initialize our solution. I found out that why is the PL crash reporter suddenly initialized before I initialized it. And then I checked the Datadog client source code, and it really uses this. So it's a proof that this PL crash reporter is really viable solution since
I see.
this large of a company uses it as well.
Good.
I will be that boring person who will say, don't try to do that at home. Like you have tasks to implement. Open Jira. Come on, you don't have time to do that.
Absolutely. I agree. All right. So then stage is yours, Tomas or Oleksandr. Any more question?
Tomas, I know you always like to look behind the curtain and you are a very curious person, always going extra steps. Could you give any recommendation to mobile devs who want to make the application more secure? Something understand.
Doesn't come to my mind, but what again?
Talsec products.
Ah, yeah,
Oh.
really. Of course. That's not really like behind the curtains. Go for it. Like implement Talsec. It's really easy way out or easy way into the security. But my recommendation, because I think a lot of developers don't really realize this, is try to minimize third-party libraries, like in general. Like if it's not really a crucial one, try to think about if you, for one, can not really design the wheel once again, but try to implement a minimalistic solution yourself, and especially with libraries that have like network communication or network access. Because if you think about it, like permissions within the system, within the operating system, is permissions are process based, right? So once the client app contains something, it has all the permissions the client app has. So every single framework technically can see every single bit of your app. So think about if it's really worth it, and especially if it has a network communication within it, it could be a real security risk. So don't import anything. Just buy. I want this. Yeah, that's awesome. Let's go.
Nice.
Try to be wary of third party dependencies.
Makes sense. All right, I think that we may wrap up the conversation. Thank you so much, Tom, for this conversation, for all the wisdom you shared with us, and I hope to we'll see you again in one of our future episodes.
Thank you.
Thank you. Thank you.